Welcome back to another session on numerical analysis. Here we will see how to find integration of a function using Simpson rule. So there are two types of Simpson rule. One is 1/3 and another is 3/8 rule. So we will see both the things. So first we have to see that what is a function and how to find. So first we will see 1/3 rule. Okay, if this is our function f of x, okay, this is b, this is a, okay, or we can write it as x0 and this is xn point. Then how to find? So we have to divide the ab interval into 2n subintervals. So if I take this and this two subinterval, so it will be like this. Okay, so for this point I can write, if the difference is h, so it will be x0 plus h, that is x1, and this is h, so x1 plus h equal to x2. Okay, now how to find? Okay, and this is x0. So here we have to construct a polynomial, okay, quadratic polynomial, okay, from x2 to x1, which will pass through x1. So it will be like this. I can plot. Okay, so this is the quadratic polynomial, so that we can write p of x. Okay, so what is p of x? Okay, that we have to find. So p of x, here we have points that we have to see. So x0 point, so for that we have the function value f0, x1, f1, x2, f2. Okay, so first our aim is that we have to find integration of f of x, okay, from x0 to x2 dx. So this I can write it as integration from x0 to x2 p of x dx. This is p of x. Okay, so we can find the quadratic polynomial and we have to integrate from x0 to x2. So p of x is what? If I write the quadratic polynomial, so it will be, so we can write here p of x. So p of x will be x minus x1, x minus x2 divided by x0 minus x1, x0 minus x2, f0 plus x minus x0, x minus x2 divided by x1 minus x0 into x1 minus x2. Okay, f1 plus then x minus x0, x minus x1 divided by x2 minus x1, sorry, x0, x2 minus x1, f2. So in this way we can write. Now we have to find this one. Okay, so how to find that we will see. So for this we can take some variable s. Okay, so s as x minus x1 by h. We can also take x minus x0 by h. So for that expression will be changed, but finally the outcome will be same. Okay, so that I can write it as x minus x1 equal to sh. Okay, so similarly, as h is the difference, common difference, so we can find what? X minus x0. So x minus x0 is s plus 1 into h. Then x minus x2 is s minus 1 into h. So now we will use these things here. And if you see the denominator here, x0 minus x1 into this x0 minus x2. What is that? This value is x minus x1 is, x0 minus x1 is minus h, and this is 2 what? Minus 2h, so it will be 2h square. Here it will be minus h square. Here it will be 2h square. Now we will use this and we will find p of x. Now integration from x0 to x2, okay, p of x dx will be what? That we will see. So again from here, this expression, what I can write here, ds equal to what? 1 by h dx, or dx equal to h ds. Okay, so that thing. So this will, if we change, then it will be what? We will see the limits first. So when it is x0, x equal to x0, then what will happen? X equal to x0, s will be minus 1. Okay, x equal to x2, s is what? 1. Then this integration is what? Minus 1 to 1, and it will change to ds. So it will be then h into ds. So we will write h. Then first term of p of x. So first term is what? X minus x1 into x minus x2 divided by x0 minus x1 into x0 minus x2. So that will be s into s minus 1, okay, and divided by 2. This is f0 plus. Second is what? X minus x0 into x minus x2. So it will be s minus 1, s plus 1, and divided by minus 1. This f1 plus first two terms, that is x minus x0, x minus x1, that is s into s plus 1 by 2 f2. So we will get this thing into ds. Now if we take the term and do integration and put the limits, we will get h, okay, by 3, and here it will be f0 plus 4 f1 plus f2, okay. So we will get this one. So as we have seen that we can approximate this function, okay, that is x0 to x2 f of x dx, okay, through this. So I can write it as this equal to h by 3 whole into f0 plus 4 f1 plus f2, okay. So this is the formula, or this is called Simpson's 1 by 3 rule. If we have two intervals, so here we have to remember this formula, that the coefficient, you can see that 1, 4, 1. So if we know the number 1, 4, 1, then we can very easily remember the formula for Simpson's 1/3 rule. Now if we have 2n number of intervals, then what will be the generalized formula, that we will see. So the generalized formula is this, from x0 to xn, okay, f of x dx, and here we have to remember that the number of subinterval will be 2n, multiple of 2. So this will be h by 3 whole into, first one f0 will be there, means 1, 4, 1, again it will start from x2, x3, x4. So 1, 4, 1, again it will start 1, 4, 1. So if you see, there will be addition of these things, okay, then again 1, and it will continue, okay. So first and the last will remain same. So f0 and fn will remain like the coefficient will be 1 plus. You see, if this is for x0, this is for x1, this is x2 and this is x3. So you can see that 1, 3, so odd numbers. Okay, so 4 into f what? 1 plus f3 plus and so on. Okay, plus f what? N minus 2. Okay, then plus you can see that this will represent x2, so even number. So but if we add, then it will be 2, so 2 multiple of 2 into f2 plus f4 plus and so on plus f n minus 1. Okay, so this is the generalized formula if we have 2n partition. Now in similar fashion we can find Simpson's 3-8 rule. For Simpson's 3-8 rule we have to consider this point x3, means we have to consider 3 subintervals. So if we consider 3 subintervals, so it will be like this. So this type of cubic polynomial we will get. So for that, okay, so that means when we have to find Simpson's 3-8 rule, for that we have to consider multiple of 3 into n number of subintervals, and if we do that, then accordingly p of x, that polynomial will change, that will be Lagrange cubic polynomial, and that will change, and accordingly the coefficients will change. Then now we will see what the coefficient will be in that form. So this is 1/3 rule, and for 3-8 rule, what to do? We have to find this x0 to what? Now it will be x3. Okay, x3 f of x dx. So it will be 3h by 8 whole into f0 plus 3f1 plus 3f2 plus f3. Okay, that means we can see here the formula 1 3 3 1. So this is the formula. Then again from this node we will get 1 3 3 1, then 1 3 3 1, and this term will be added. So very easy to remember the two formula if we know the number. So 1/3 rule, the formula is 1 4 1, and we have to divide the total interval into 2n subintervals. And for 3-8 rule, the formula is this 3 by 8 into h, and where the coefficients are 1 3 3 1. Okay, and if we write in this way and add and find, then similarly for 1/3 rule you can find the generalized rule 3 by 8 Simpson's rule. Also the beautiful thing is that this 1 4 1 and 1 3 3 1 both are palindromic numbers. So in that way also we can remember those two numbers for those two formulas.